Okay, I'm going to start here now with our session for Introduction to Networking. Our main objectives is going to be able to define and give examples of networks. We want to be able to identify what a PAN, a LAN, a WAN, a MAN, all these different acronyms that are out there that we're going to be using. Obviously, those are words, as some of you be shocked that we don't use in front of users because they're not going to understand one word that's coming out of you. Identify the devices used in the networks. Identify the types of cables and connectors being used. Can somebody help us out here? What is a computer network to you? Jordan.
Computer network is so hard to explain. It's interconnected communication between a bunch of computers and other devices on the network. That's what it is to me. Sending data back and forth.
Yeah, it's as simple as we can put it, right? Everyone
I
agree?
suppose.
Interconnected computers, networks, basic devices, or computers, or anything that can be either wirelessly or by cable. Obviously, nowadays, we're not only grounded to that cable anymore. We could actually go wirelessly and connect wirelessly. Thank you. So, as Jordan alluded to, a network links computers for communicating, basically, and then sharing information. Prior to this, we had to use what we called sneakernet. Anyone know who sneakernet is? Right before the internet. It was the best invention they ever created back in the 80s. It was very, very fast. Very, very fast. Nobody knows that? I think that it was about, I think it was 1.44 megabytes per second, something like that. Yeah, as long as you can run in your sneakers to the person and get there as fast as possible, you can get the file to them. That's why it was called SneakerNet. There was no networks. I'm not joking. That's what it was called. So when this invention came out, the operating systems of 3.11 of Windows gave everyone now the capability of no longer having to actually get up and move. And we look like Wally now. We're all getting a nice little round, and we're going to be floating in a chair real soon. As Lazaro's nice, beautiful chair he has there. I'm very jealous about his little headset and chair. Although he kills computers, but we're not going to get into that conversation. So obviously a network must be able to provide connections, communications, and services, depending on what type of network each one has its components inside. Major components are client, server, network devices, and media. Everyone know what a client is exactly? They understand?
It's the host that requests information to the server, and they're referred as the client.
Mm-hmm. So any device that can connect, iPad, a mobile phone, any device that is either mobile or a computer itself is a client, because he's the one requesting information from the network. Even if you're just going out to the internet, you do realize you are a client that's going out to a web server asking for information. The web server is the one that is, his job is to be able to provide the resources with email, your internet websites, download files, be able to collaborate on SharePoint. All these are servers. Even putting Excel files in one location so that everybody in the department is able to share. That is usually, if it's done correctly, on a server. Obviously, there's different variances of types of servers, but its main job, that's what it is. A proxy server, we'll learn soon that it's the one that talks in our behalf to go into the internet. You actually proxy through him. And our network devices. We have our switches, we have our routers, we have our access points, we have repeaters, we have satellite, we have a bunch of different actual devices that help us communicate throughout the network. And lastly is the media. It's used to interconnect devices, be the wire itself, wireless. Obviously, you got fiber optic too now for the light. So that is the media. That's the things that we travel through. Any questions on those components? We need to be able to identify where they are in the network and what they are. So the copper is not a network device. Copper is a media. So is the fiber. So is the Wi-Fi signal. The access point, though, is a network device. Questions? So we have to obviously be able to be adaptable. These are many kinds of networks out there. We have to learn to adapt to and to approach depending on what is needed and depending on the client's current network configuration. We're going to learn these things real soon. So if we are not able to adapt to every given situation or have the growth mindset to continuously try to learn all the new types of technology that continue to come out, it will get harder and harder. Because I assure you, from when I started, that we had the coaxial and everybody was riding the bus at 50 ohms to where we are now, it's night and day. If I would have failed to continue to broaden my education, then I would have been stuck in the 80s. Probably with a different haircut. No? All right. So let's continue here. Jordan, if you can help me reading out this one here.
Basic network topologies. Arrangement of connections between computers, also called physical topology. A mesh network, each node on the network is responsible for sending and receiving transmissions to any other node without a central point of communication. In a ring network, nodes from a ring. Bus network, all nodes are connected in a sequential line, an older topology. Star network uses a centralized device to manage traffic on the network. And a hybrid network uses one or more networks to combine connections for better communication. Example, star ring, star bus.
Thank you. Here's a topology visual representation. So we need to understand the internet and or network. The internet itself obviously is a hybrid. It's a ring / mesh / star, depending on where you are. Usually the star network is the one that's inside your facilities. Those are the ones that are connected directly to a switch, and you can think of it as a star because all cables come into it and it goes out to the people. So it's like as you can see here in the picture, the strings just come out. That would be a star topology. The ring topology is an old network. This is also the old network, the bus. If you remember when I first started our conversations of the bus network, this is the one with the 50 ohms. There's physically no line, one cable going straight through the whole facility. That's the bus. You would have to come in with a multimeter reader and read 50 ohms to see between each section when the 50 ohms stop. When you get 25, you stop there because somewhere in that section somebody did not put the little closing pin, the BNC connector. We twist and lock it. Even if you're not using the port, you needed to twist and lock it so it could send the signal right back to close the, you could say the loop, or the signal back and send the signal down the loop, the bus, not the loop, wrong words. So if it didn't continue sending the signal through the whole bus went down. Not one user, everyone on the bus goes down. So the whole facility will go down. This one here is the ring topology. Usually was used within token ring. It's not being used as much. As you can see, it's the same problem. You had to, although sometimes there was a switch in there, it still, all it did was just create a virtual ring loop. It was it would vary between 14 and 16. And if you introduced a computer that was on 4 on a 16 network, once again, there goes the whole ring. It went down because you're talking at one speed while the other guy is talking at another speed, and it's catastrophic. It didn't have an auto sensing feature. You'll hear everything beaconing, including the switch. It'll go. Should have seen my face when my boss ran in. He didn't tell me anything. What do you want? I look like Lázaro when I didn't put thermal paste. Lastly is the more robust and costly one, mesh. As you can see, it looks very fancy, and that's because every single computer here is touching each other. There is no point in break. So if this connection dies, I don't really matter because I could still go through here. Has much more, obviously, cost if you're doing it over a wide area network, which they call the WANs. Even inside a facility, you can see that's not really possible. You usually don't have a mesh network inside a facility. This would be more of a virtual WAN, be that it's public WAN or a private WAN. Anybody know what's the difference between a public WAN and a private WAN? The public WAN is you could say the internet. The private WAN would be a private wide area network for a given company. Only the company can see that network interconnects all facilities within the company, be it globally or within the United States or various cities. There, a lot of them pay for a mesh or as close to possible to a mesh network to be able to facilitate the, I call it, when you have a catastrophic event, nobody is down except for obviously that one facility. Minimal impact. Any questions on a mesh network, a star network, a bus, or a ring?
I got a quick question about the private WAN. Usually those are like T1s or T3 connections that they get from the providers, right?
Yeah, OC3s also, correct. It's all depending on the size of the bandwidth that they need. Some of them have fiber coming straight into the building. That all depends on the amount of connection you need to come into the facility or for your company.
Sounds expensive.
Oh yeah. Well, you do that because just one example. Let's say I have a mesh network that's a WAN, right? If I would pay internet for every single facility, it would cost me more than if I put in here a fiber connection or an OC3 ring here and an OC3 ring here going out to the internet. I still am already paying for all of these to be in a private WAN. At the same time, now I've created a gateway where I put a proxy server here and a proxy server there, so that if anyone in the company within the United States needs to go out to the internet, they go out through those proxies. You save costs, and you save costs, and and now you control who and when they're going out.
Okay.
And now you also control security. Security now is tight because only through these doors can you come in and out. No risking that some little IT guy decides to connect a DSL or some weird thing over here to give Pepe some access to the internet.
A rogue.
Well, yeah, that also rogues. Those are things that can happen, but obviously that's later on when we're mentioning it. I think it's in the second half of this. Any other questions in reference to mesh, star, the bus, or the ring? So what would happen if this cable here broke? What do you think?
It wouldn't work.
The whole thing goes down, right? Same thing with this one over here. On this one, only the user goes down. Same thing. On this one, even if I lose this connection right here in the middle, do you agree that this site is not down?
No.
The site's not down because he could talk to him, he could talk to him, and he could talk to him. So he'll be able to get, he just can't go directly to this guy, but he can go this way. Same thing, that also happens in facilities where they have a lot of switches, where they have something like this, and to avoid this continuous ring of stuff going the wrong way, they have a thing called spanning tree where they kind of control and or turn off, not turn off, that's a bad word. It's called warm. So it's kind of there, so the connection's still on, but I'm not gonna transmit to you because I know it's faster if I go this way. Make sense? So that way it doesn't continuously create a loop, because then it starts going crazy trying to figure out which way it needs to go. Types of networks, as we stated. This is a picture here of the client-server network that contains both clients and a centralized server. This is a visual representation. Obviously, in most cases, they're going to be going into a switch, including the server would probably go into a main switch where it's probably got gigabit Ethernet or maybe 10 gig Ethernet, while these guys are maybe at 100 or a gig, depending on what you buy and how many bells and whistles you have. Any questions in reference to the client-server relationship and what they are and the types of networks by resource? So can, Carlos, can you name for me a type of client that you have in your house? Name a client resource that you have in your house.
Hello, can you hear me?
Yeah.
A phone.
Okay.
Would that be what considered one? A laptop.
Okay.
Um,
Can you tell me what servers you use from your house?
mm, mm, you mean like the router? Like, is that what you mean?
That would be a network device. Pablo will be able to help you out. Pablo, what servers are you accessing from your house?
My servers.
Yeah, what server? You probably daily you're accessing many servers, no?
Yeah, I mean, what server am I using right now? I guess Zoom servers.
That's correct. Zoom server. There's a server hosting this, right? Being able to relay everything and create it.
Yeah.
What other ones are we using? We're using a Nearpod server, maybe?
Yeah. Also like email.
There you go, guys. Yeah. Email, your email server. Daily you're going into Gmail. That's a server.
We got
Any other ones? Let me think. I can't think of many other ones.
bank state, like a
There you
bank.
go. Your banks. Your banks have servers that you're going into. So
Social media
you'll be
server.
surprised how
Google
many
Classroom?
resources are. There you go. Google Classroom has a server. Servers are everywhere. We just don't realize that we're using them until we obviously think about it real deep. All these resources that are out on the internet, be internal or external to a company, even when you are home, you are accessing servers. They're giving you resources. You're able to get information. If it's not on your computer and you're accessing some type of information, then it is a type of server. Make sense? Thank you. Next slide. Daniel, you can help us read.
Oh, sorry. Types of networks by resource location, peer-to-peer. Peer-to-peer, all clients, no servers. All PCs shared networking burden. Works well for a very small network and becomes awkward with large numbers. Rule of thumb is no more than 10.
Yeah, you don't want no more than 10. And usually it was great. Anybody know where I used to use this? No, you guys don't even know. I'll give you a hint. It was the Xbox. We used to do this with the Xboxes back in the day, create a small little peer-to-peer network. Everybody had to bring their own little television. and a,
They do
and a,
that.
still
They do.
and a
They
six-pack on
do
the other
that in
end,
a
right?
lot of like Hispanic countries, you know, to
Like a
like
LAN
game
party.
like their network game.
Yeah,
Yeah,
exactly.
LAN party.
That's what it is. It's a LAN party. That's what it is, exactly.
Usually
It has
party.
no internet, if you notice. It has no external resources that it's getting, and is usually only used obviously in very small networks. It's not very practical because everybody's got to be able to connect one to another. Another one was Game Boy. That was another peer-to-peer network.
Those were the days.
Yeah. Next slide. DeAndre, can you help us with this one? DeAndre? Alexa, I guess, if you can help us out.
Personal area network. Computer network organized around one person. Interconnects devices within a short range using Bluetooth, FireWire, or USB, among others. Includes one or more PCs, phones, peripheral devices, video game consoles, and it is very flexible.
Yeah. PAN obviously is exactly that. It's your own little network. We do it all the time, right? We have a little Bluetooth headset. We have our connection directly to the printer. We don't even have to connect the printer nowadays to our wireless network. It has its own network already. And it tells you that you can connect to it and just send it information. Our phones, right? Some people connect their iPhones and are able to sync, or their Android phones. So that we can just simply see that it's personal. It's in my area. Now, can't get further than usually than arm's length. Obviously, I'm exaggerating, but you get the point. It's not meant to connect anything except for you to usually resources around you, and or some people use it, you know, to be able to send each other information, be one phone to another. Any questions? Next slide. Local area network. Teresa.
Local area network, collection of computers located in a relatively small area like an office or building. All devices are connected by a common medium. Allows sharing of data, peripherals, software, and storage. Provides high speed and low cost. LAN topologies includes bus, star, and ring.
Thank you. So the LAN is the local area network. We will live and breathe on what's LAN and WAN the majority of times. If we are IT professionals, we must know these very well. The PAN, obviously, a lot of users are very familiar, just don't know that it's called a PAN. We all agree, I'm pretty sure all of you understand, if you've used your phone to connect to your PC, that's a PAN, so you know what a PAN is now. Anything that is just connecting Even your keyboard, if you have a Bluetooth keyboard connected to your computer, that would be a PAN device or PAN network, sorry. A LAN now has a centralized, usually maybe several switches, depending on the facility size, where every network device is connecting directly into this switch or various switches to be able to use as a medium or media to be able to get across. It provides obviously the bus, as we said, some of them is a bus. That's not really being used anymore, but I don't know, maybe some people are still there. The bus is still in there technically, because if I have several switches, right, stacked on, they are technically riding on a bus because they intertwine each other just with the cable. And some of them, if it has several rooms, create a large ring, virtual ring, so that when they all connect into each other. So you'll have several switches which have just dedicated fiber ports only. And then you can create a mesh. All the switches will create to go to those centralized fiber switches. And now you have eliminated a ring and created a mesh. So there's a lot of different ways of setting it up, your LAN. The main purpose, obviously, it is to allow the file servers, your printers, your access points, your users access to the data. Any questions? Are we sure? We understand 100% of LAN? Next slide. Justin, me out here.
Wireless LAN or WAN. Yeah, wireless LAN. LAN, which uses wireless connectivity, can be public and unsecure or private and secure. Provides flexibility and mobility.
So the wireless LAN is obviously exactly the same as a LAN. There's no variance except for its media. Sorry, excuse me. Media is the one that's wireless. It's meant for a local area network, which gives the devices capability to be able to share resources, be sending it to a printer, sending it maybe to the access point, and the access point maybe with a cable is connected to a switch, and now it will send it to the printer. It all has its capability and flexibility, obviously, because now you can mobilely have devices, including scanners out there. There's sophisticated scanners that you could put in the order number and scan the load of the information of the truck that just came in. You could be scanning all the serial numbers on that order with ease. No longer do you have to go and write it on a piece of paper and go back or carry around this clunky, humongous laptop just to be able to fill out an Excel sheet with a wireless LAN. Any questions?
I have a question about LAN.
Mm-hmm. Okay.
So what would be the host for LAN specifically that are the
Switches.
connection?
Switches on a LAN, you're only dealing with, the majority of the time on a LAN, it only speaks in MAC address. So you only need switches. We're not talking about internet yet at that point, because the LAN is only to be able to talk to everything, including a router that may be on the actual network. But the LAN is local, only here in this building.
So that's just essentially going to be the host.
The switches. The switches are the ones that interconnect everyone and allow them to be able to connect. That would be obviously in the topology where you're using a switch. When, like I said, the previous ones prior to this, the bus where that's that long cable, there's no switch, it's just one long cable. That's not being used that I'm aware of. I mean, if it is, good luck to those people because I believe that's not being used.
And then the switch is built in each computer individually, so essentially everybody's each other's hosts.
No, the switch is a device that sits on the network itself. For instance, you have a Comcast in your house, or do you have AT&T? Who's your provider?
Yeah, sure, like Fusion or whatever. Yeah.
Okay.
So,
Now you look at that device. That one's really a SOHO. It's a small office, home office router. Okay, that has several ports in the back, right?
Yeah.
It has several ports and it has an antenna. So it has actually 3 devices in one. It has the router because it's going to allow you to go and connect out of the facility. The job of a router is to be able to route traffic from the LAN to the WAN. That's his job. He's going to translate from MAC address to IP and go, hey, you out there in the internet or in the WAN or private, whoever it is out there, here. You can care less after that. He send it, and it's somebody else's job to go and fix it or come back and say, I can't do it. So now the other thing that you have in there is a switch that interconnects everything in the LAN. His job is to talk in MAC addresses, which we're going to learn real soon what a MAC address is or what layer 2 is.
So then the switch is essentially in the network.
The switch is a device that's on the network, and its job is to be able to create separate broadcast domains to not saturate the actual network. What I mean is that there's also another device that used to be called the hub. The hub is very dumb. He broadcasts everything. In other words, if you talk to me and I'm the hub and you say you want to talk to Carlos, I actually scream it out to Mohammed, to DeAndre, to Christina, to everybody that's on the network saying, hey, he wants to talk to Carlos. And Carlos says, oh, I'm here. Hey, everybody, Carlos is here. That's how stupid he is. He won't adjust at all. He screams it out to everybody. In reference to the switch, it looks identical, but he is smart. He is actually tracking the MAC addresses. The MAC addresses are the ones that are on the actual computer. That will be the actual RJ45 or the MAC card that you have in your computer where the cable gets connected. That has an address, which is considered equivalent to a serial number. Doesn't get duplicated. Never gets duplicated anywhere. So now he can be able to track who is where and what MAC address is who. He can care less about IPs. He's not looking at IPs. He doesn't even know what an IP is. That's not even his language. All he speaks is in MACs. As soon as he finds out what your MAC address is, he associates it also to the name. He now has something to be able to talk to everybody. So he'll just basically grab the MAC table and sends the information back to each port that pertains that MAC packet. That's his job. He doesn't speak in IP. That is a very dangerous thing if you ever think that you can maybe configure it via IP. That's a different side of the router. That's the configuration side. But my job as a switch, I have no idea. This is a layer 2 switch, a simple switch. There's more sophisticated switches that go all the way up to layer 9, but we're not covering that. Just a simple switch. Any questions on the LAN? So in this picture here, we're seeing a access point who is sophisticated enough to actually be a switch, a wireless switch. There's access points who are not smart enough. They can't do switching, and they actually just let you connect to them, and they send it back through a cable to a switch. So that's depending on the job and how you want to set it up. Most of them now come up with the capability that you can actually set them up if you only want them to be a bridge or if you want them to actually act as a wireless switch. Right. Any questions on LAN or wireless LAN? We must understand it because these are the pieces of the network. They're all intertwined to each other, and we need to understand where we are, because when we get to the sections of TCP/IP, it's gonna get very interesting.
I have a question.
Yes.
Besides the router being connected like by a wire, everything else is wireless, right?
No. The computers usually are connected by, and servers are connected by wires to the network, which goes to the main distribution frame or the main closet. And then those panels connect to the switches. Usually, if you're dealing with a business, the majority of them won't pay for wireless. Plus, wireless creates a lot of problems. You have a lot of retransmit. So it's not, although it's fast nowadays, it's not as good as wired. So,
No, I'm saying like in the wireless LAN, like all
I'm
the
sorry. I'm
devices.
so sorry. In the wireless LAN,
Yeah.
sorry about that. The router and the access points are the only ones that would probably have a cable connected
Physical?
to them.
Okay.
Yeah. Now, that's the access point that's acting as a switch would do that. Now, there's ones that are used as bridge or repeaters, which don't need a cable. They wirelessly communicate back to the other one that really has the cable to the router, and they just extend the signal. So he just repeats it. He goes, yo, you guys out there. All right, now you, router, here you go. He just wirelessly connects. That's called a repeater. It's still an access point, but his job at that time, he's just throwing packets everywhere wirelessly, but he doesn't give you a connection to the internet. He knows where the connection to the internet is. He will let him know, but he will just be repeating. It's obviously slower because he's just a bridge to get you from here to there. So you gotta have to hop over him to get to where you want to go. Usually people have these things in their house, or what they call the extenders, and they're out in their backyards or to the second floor of their house to be able to use them. Any other questions on the wireless LAN? Next is our wireless mesh network. We can have, who we have here? Christina, if you can help me out here.
Wireless mesh network. In a typical WLAN clients connect wirelessly to an access point AP, which then connects to another connectivity device such as a router or switch. The key defining factor of a WMN is that it has multiple redundant connections, all using the same SSID.
So everyone know what an SSID is?
No.
The SSID is the one that usually you see. So when you go and you turn on your phone to look for a wireless network, that is the identifier of the network. It's the one that gets broadcast. So depending on your house, if you have Xfinity, you might even see Xfinity out there and your local one. So these basically are all wirelessly connected. As I stated before, you'll see here, that's the wireless mesh network. So the links between these that are dotted are obviously wirelessly. Nothing is wired except for the gateway. He is the one that you see over here. That's the example that I was talking to you about earlier, where now these guys, although there may be routers themselves, but they're just repeating the signal within themselves here, but the only one that really has connection to the internet is here. One flaw in this, obviously, is since you have the same SSID, you have to be very careful on what channels you're broadcasting. One example that a lot of people need to know is that you need to be broadcasting it either on 1, 6, or 11. There's obviously, I think, 12 channels, if I recall correctly, on on the lower band. I'm not going to get into the higher band. So you need to make sure that if you have 1 here, this is 6, this is 11. And this guy could be 1, this could be 11, and this can be 6. The channels can't be near each other. If not, you're going to have problems. Because when the device is getting into one zone to the other, since he's on the same channel, he doesn't realize that he's in the wrong zone. So instead of updating the MAC address, he continues to talk on the same channel, but to the wrong MAC address. So he's far away from one device that he was connected to, but since the channel is fine, he's not going to update his tables to figure out he's got to go to another MAC address to send the packet. So the other antenna that he's close to ignores him. You're not talking to me. Got nothing to do with me. Don't Tony.
I have a question. Is this like what they use like in schools?
Some schools are using this. Hospitals are using this to be able to even interconnect facilities. So you'll see sometimes the big antennas right outside the facility to be able to facilitate and connect to the whole building. It's cost obviously very cost effective because now no longer do I have to do drops throughout all these buildings. I can now just extend with the wireless mesh. There is some of them that are a little bit more sophisticated and much bigger, but these are usually the idea of an access point and or a router doing these jobs in an area. Not very wide area here. This is still a LAN. Any questions? So you can pretend this is your house. You say that this is your living room. You might put a repeater out here in the backyard, one in the study, maybe one in your room or something like that, because you have spotty connection throughout the facility. Doing this now, you won't have a bad connection for the device. Obviously, there's still latency. We all agree I'm going to have several hops to be able to get out of here. At the same time, I'm not losing packets and I'm not degrading on signal. And that's the reason why people sometimes set up a wireless mesh network around either in the office, schools, or a facility, depending on the type of cost associated and what they can actually purchase. Any questions or doubts? All right, now we have a MAN. The MAN is very interesting. It's a metropolitan area network. Obviously, can somebody give me an example of who may have this? I'll tell you, every single city that is a city, not a town, has a MAN. No jokes allowed. No, I'm not joking. MAN as in metropolitan area network. Come on, guys. Nowadays, you could be doubtful, but hey, it's depending where you're walking into. Stop it. You're going to get sued. All right, here we go. Seriously, guys. Come on. Come on. Wake up. Take a wild guess. Take a wild guess. Who will have a MAN, no matter what? Every single city has this type of service which requires a MAN.
The Wi-Fi?
Would it be like cameras?
There we go. That might be a MAN on a MAN, right? Police. Police run on a MAN. Police network, right? It's a private network, but it's only within the city.
Like local government?
Local governments have MANs, right? Usually that's where it's confined to only that area. Once again, we need to understand there's no internet connection when I talk about a MAN. We understand they may have in the back a proxy or whatever it is that they have to get out to the internet. That's something else. As for in reference to what we're talking about and where it's connecting all their lands within a geographical area of a city or Miami-Dade County, you know, for the another man, which is out there is for sometimes for hospitals, right? Some hospitals have a very large coverage to, who is it, like Mount Sinai may have a man, for instance. I think they're one in the beach, one over there, one on the other side. Any questions on what a man and what it does and how it covers? So we had our LAN, which is a short distance, usually within a facility in a given area. The wireless LAN, again, is within a confined area. Now we've gone a little bit further. Now we're going into the city, which is the MAN. That's how much it's covering. It could be obviously miles away or blocks away. WAN. Now, our WAN is obviously much larger. The scale, there is none. It's global. It's even obviously
SMU.
all the way out to Mars right now. We have a WAN. So NASA speaks to the rover over a WAN. We agree it's not a LAN. To be able to speak to the rover, it's a wide area network. Be that it's private, that's fine and dandy, but it is a WAN. It always consists of multiple LANs / or MANs, depending on what we spoke of before. It must consist that because that's what it's doing. The WAN is interconnecting wide areas of network. Geographically, if I'm connecting, the one that would have that would be FBI, CIA, the Postal Service, anyone who has a geographical challenge to be able to connect, be private or public WAN, it's possible. Any questions on what a WAN is?
So would Google be like a WAN?
Unfortunately, Google is a server. WAN is the service that Comcast provides to you to go out to the internet. They're an internet service provider, or they call ISP.
Private network, pretty much.
Ooh, I'm sorry?
A WAN is like a private network.
It can be private or public because the internet is a WAN.
That's
It's
true.
also the wild, wild west. But you could
But
think of it, it is an internet. The only variance is when you change it from internet, you change the word to intranet. Intranets are also a WAN. So the internet is that it's a public network that's intertwined with each other and they can physically see each other in wide distances.
So like the only thing that makes it a WAN is just the fact that it's just much larger in a geographical scale, right?
Exactly. That is the only variance here, is the geographical scale and distance that is covering. So a LAN is go ahead, sorry.
As it doesn't Google offer internet to certain places?
I wasn't aware of that. I guess then there would be a ISP. Then Google could be an ISP. I know Yahoo is an ISP. I'm not sure if they're still doing it, but Yahoo used to be an ISP, and AOL, but I didn't know Google was providing that. That's pretty cool. So as long as you're getting out of your facility and traveling large distances to get there, that's considered a WAN. Obviously, the router is the one that's going to connect the LAN to the WAN, be that it's a public WAN or a private WAN. In the public WAN, we usually call that the internet. That's the name. And then the private WAN is called the intranet. The way I remember this is just like you see it. Interstate 95. I-95 is an interstate. Goes from one state to another. While your intra is 826. Intra-highway. It's only inside the state. So if it's an A, it's in a small area, not the whole world can see. It's confined to just your company usually. Now there is obviously VPNs and other things out there, but when we're talking about here is geographical areas. You must be able to identify what a LAN is, which is your local area network, locally here. Your MAN, which is a metropolitan area, now covering city blocks or counties. And now our WAN goes and connects multiple LANs/MANs together to be able to cover the wide geographical area. Any questions? So, next slide. Can somebody tell me what is number one?
Mesh network.
Everyone agree, mesh?
Mhm.
Okay, someone else can help me out with number two now?
It's Star Network.
Okay, thank you. Next person, number three.
It's a common bus.
Okay. And the last one.
Ring.
Ring.
Yes, very much. Thank you. We're gonna stop here and take a break, guys. Refreshed from our break. We can continue to the next slide. If someone can help me out, fill out the chart here. What's LAN stand for?
Local area network.
What's this geographical confinement?
What do you mean by that?
We understand that all these are just a representation of a geographical confinement name to a network. They're all network. One network. The only variance is spotting where in the network you are. So geographically, where are you confined on a LAN?
Like your room, or like
the
like
building
a
that
room?
you're in. So if I worked in I don't know, in any facility. Say I was in Biscayne and I was in one of those towers there, and somebody owned the whole building. That would be a local area network.
Okay, I understand that.
It's many computers connected to switch network usually, and they're confined geographically to an area. Usually it's a facility. One hospital by itself would have a LAN, may have also a WAN. Can somebody tell me what a WAN is?
Wide area network.
Okay. And what is his geographical confinement?
Essentially, there is none.
Well, technically there is.
It's a wide area, so it's like they can travel country to country. Or
Would a WAN be inside a LAN?
No.
So that's his geographical confinement. Is external, widely, in other words, it has to be far distances and it has nothing to do with it. Reason why we need to understand this is that the local area network speaks in MAC addresses. There's all what we call layer 2. There's also obviously some other protocols in there, so I'm not going to just say MAC address. WAN speaks in IP, Internet Protocol. It must have a 10.216.8.1 address associated with it. As an example, I'm just giving you an IP address. Here, it's a MAC address. So it'll probably be 8F:2E:, a whole bunch of other mumbo jumbos, usually 8 pairs. So that's the geographical confinement and how we're gonna get into the details how they apply, but we need to understand where in the network it is, because when we're troubleshooting the network, we definitely need to understand what's what. That way we can then tackle the correct device that's giving us the problem. Next one is PAN. Can somebody help me out with PAN?
Personal area network.
Okay. And what's his geographical confinement?
Several feet.
Basically.
Like Bluetooth. Yeah.
Bluetooth, whatever the media's confinement and or requirements, that's what we have, right? Bluetooth and or whatever other wireless technology we're having, but it's usually within one person to those devices around him. Any questions on PAN? Okay, can somebody help me out with WLAN?
It's going to be wireless LAN.
Okay, wireless LAN. And what's his geographical confinement?
I would say like
what's his name? Let's look at his name. What does it say?
wireless LAN.
And what does LAN mean to you?
So it's a local area network. So
Correct.
it's not that far away, but it's wireless.
Like an office or?
Yes. The wireless LAN would be in an office, for instance. All the wireless access points that are connected to each other, either directly to a switch or to each other, right? Because they showed us a wireless mesh version. There's also the wired version of the wireless LAN where all the access points get connected back to the switch. All they're doing is giving a connection for all wireless devices in the facility to be able to connect back to the LAN and then going out the router to the WAN if they need to go out. If they just need to stay in the LAN and go directly to a server, it can do that also. Well, it doesn't need to go out to the WAN. It's just providing wireless connection to all devices in this confined area to the LAN. That's his job. Obviously, there is other devices that have several jobs and other things, but plain and simple, wireless LAN, that's all it is, without mixing anything else in reference to the wide area network. Man, who's man? I am man. No, come on, people. Help me out here.
Area network.
Metropolitan area network. What's his geographical confinement?
It can cover from like blocks to several miles. I think like 10 miles, right?
Well, yeah, basically a city, even Dade County, right? Miami-Dade Police. I'm pretty sure theirs covers a big radius, right? That's a man. Doesn't connect out to the internet, right? We're saying that you're only using it for themselves. We agreed there is capabilities of doing it if I have a router that goes out to the internet. But as for what the job of what a man is, it's usually a private network in a confined location, which is usually city blocks, depending on how much you want to pay, to interconnect all these facilities, all these LANs together, including the devices that are out there, which are the actual police units, right? All these police units now have a computer inside there, they're actually cop cards. They're running on that man. They're not on the internet. Could you imagine if somebody hacks these things on the internet? That wouldn't be pretty. Be interesting, but it wouldn't be pretty. Any questions?